Welcome to the AI Research Roundup. I'm your host, Alex. Alright, today we're diving into a fascinating new paper published on May 1st, 2025, titled, A Survey on Large Language Model-Based Human-Agent Systems. This paper is quite significant because it offers the first really comprehensive look at what the authors call LLM-based Human-Agent Systems, or LLM-HAS. These systems, well, they aim to tackle some big challenges we see with fully autonomous LLMs, like their tendency for hallucinations, which is when these models generate plausible, but incorrect or nonsensical information, and also their difficulties with complex tasks and safety. So LLM-based human-agent systems try to improve this by incorporating human feedback and control. And to help researchers and anyone interested in this area, the authors have also shared their GitHub repository for this work. It's basically a curated list of resources. Think of it as an awesome list, with the survey paper itself and many other related studies on these LLM-based human-agent systems. They're keeping it updated too, so it's a great place to find current information. Okay, so this first figure we're looking at, Figure 1, it really gives us a great visual overview of the structure of these LLM-based human-agent systems. It highlights that these systems are generally composed of 5 core components. First, there's environment and profiling, which is all about, the context they operate in, like the kitchen scene shown, and also defining the roles and capabilities of both the humans and the agents. Then we have human feedback, which covers the different ways humans can provide input, such as giving corrections or guidance. Next up is interaction type. This component describes how humans and agents actually work together. For instance, they might be collaborating on a task, or in some cases, even in a competitive setup. Following that, we have the orchestration paradigm, which deals with how tasks are managed and how the timing of interactions is handled. And finally, there's communication, which outlines how information flows between everyone involved, whether it's direct conversation or other modes. Together, these 5 components really define the architecture and functionality of these systems. Alright, so Figure 2 really zooms in on 4 of those components we just discussed, giving us a much more detailed taxonomy. For human feedback, for instance, it breaks this down by type, like evaluative feedback, which is about judging quality, or corrective feedback for fixing errors. It also considers feedback granularity, meaning whether feedback applies to the whole task or just specific segments. Then for interaction type, we see subcategories of collaboration like delegation or supervision, but also distinct types like competition and even co-opetition. That's a scenario where entities might cooperate on shared objectives while still competing in other aspects. This figure similarly details the orchestration paradigm and communication with their specific strategies and modes. Alright, so we mentioned interaction type earlier, and specifically that collaboration is a key way humans and agents can work together. Figure 3 now. It gives us a much clearer picture with some visual examples of these collaboration subtypes. For instance, we see, quote, delegation, where a human hands off a task like an inventory update for the agent to handle on its own. Then there's supervision, with the human monitoring the agent, perhaps as it checks wiring. Cooperation is shown as them actively working together on one part of a job, and, quote, coordination focuses on syncing their actions to avoid issues. These examples of delegation, supervision, cooperation, and coordination really highlight the nuanced ways humans and AI can collaborate. Overall, this survey provides a much-needed, structured way to think about and design these LLM-based human-agent systems, helping us build more effective and intuitive interactions. It's a great roadmap for future research. Well, that's all for this AI Research Roundup. Thanks for tuning in. I'm Alex.